All right, guys, we're back. I'm back in the classroom. Feels good to be back, and I've got my document camera here, so I'm all ready to do some tutorial videos for you with your graphing calculator. There's a couple of things in there related to the normal distribution that I want to make sure that we highlight. And so let's get to it. First up will be the TI-84 calculator. So if you're rocking one of these bad boys, then get that ready. If you have an Inspire or an 89, you're on the wrong video. So click the other video that's over there in the tutorial links. So I've got a data set in here, so I'm going to be using that later. If you want to put that same data set in there, I will tell you where that is located at that point, and then you can stop the video and enter the data. We're going to start out with the normal distribution just by itself, and then we'll get into that whole assessing normality thing. So let's take a look first at all how we could do some computations with the normal distribution, and that's where we'll begin. So right off the bat here, I have to reverse my video, one quick video setting here. Otherwise it's backwards for me. There we go. I want to call your attention to the distributions button. It's right here. It's in blue. So that's the button where we're going to go. And we're actually going to use that a fair amount this year. So it's a good one to remember. It's kind of like the stat button that's over here, right? We use that one a lot too. So I'm going to show you what it looks like when I hit that distributions button. So distributions, and boom, here we go. We've got a whole lot of different distributions that the calculator can do. All three calculators have these distributions. So don't worry, 89 users and Inspire users are going to learn how to do this too. Your friends will be fine. We never use the first one. We always use something called Normalcdf. The normal, obviously, stands for normal distribution. The CDF is cumulative density function. The C is for cumulative, means it's going to add it all up. So basically, what we were able to look at in table A is what your calculator can do. And the nice thing about the calculator is it doesn't have to be standard normal. It can be any normal distribution. For example, I have told you before that the heights of US women are approximately normally distributed with a mean of 64 inches and a standard deviation of 2 inches. So if I want to find the proportion of women who are less than, I don't know, let's say 60 inches tall, less than 5 feet, then I can do that here. Now, one thing about the TI-84, it does not understand the concept of infinity. So that lower limit should be negative infinity, but you can't put that in here. But what you can do is make it a really tiny number. So that's what we've got here. If you don't like that, I always just make it a negative and I just put a bunch of 9s in here. And I'll do the same thing for positive infinity. I'll just put a bunch of 9s in there. Okay. Now I said you know that they're taller than 6 feet, or sorry, 5 feet. So let's put in 60 inches. All right. And the mean, let's say, was 64 inches. And the standard deviation was 2 inches. And that's what I mean. You don't have to go to the standard normal distribution. You can just go right here and it can handle the calculus to find out that, oh yeah, sorry, you got to hit enter again, that woman who is 60 inches tall is taller than approximately 0.02275, or let's just say 2.28% of all women. Now, the nice thing about the way this calculator works is with the table A, you know, you'd have to convert to a z-score, then you have to look up the z-score. And then if you had to do one of those ones, it was like between two heights. Like if I said, what's the probability or what proportion of women are between 60 inches tall and say 66 inches tall, I can do that directly by just changing my lower limit to be 60 inches tall and my upper limit to be 66 inches tall. You can see the mean and standard deviation are the same here. Okay, I'll hit enter. And oh, look, about 82% of women are between 5 foot and 5'6". So this command allows me to take any normally distributed data set. What it's doing in its little brain there is it's figuring out the z-scores and using the standard normal distribution and some calculus to find these areas. But we don't need to really do that. We can use the calculator and just go directly here. And if you want to switch distributions, okay, you know, the US men's distribution is a little bit different. the mean on that one was, what was the mean on that one? 68 inches tall, something like that. I don't remember. Oops, sorry. 68 inches tall here. And standard deviation is a little bit bigger though for US men, so it's 2.5. And we could do a calculation like what percent of men are between 5 foot and 5'8". Oh, that's 50%. Okay, so there you go. That's using the Normalcdf command. I know I went through that pretty fast. This is a video. Pause it, rewind it, and go check it out again, and it'll show you how to do all. I'll show you how to do all those calculations. All right. The other thing that I wanted to show you was how do we assess normality with this calculator? Okay, now earlier I showed you how to make a histogram, and so I'm going to go back in here and go to my histogram. Now I have deleted a lot of my data, so it's all in list 1 here. Now I told you I would tell you what page number this data set's on. It's on page 125. It's all the unemployment data from the various states in 2009. Remember, our book's a little dated, so the unemployment data right now would look drastically different given all the COVID and all that. All right. I'm going to go ahead and make this histogram and then just take a look at it here. And I'm going to go to my zoom and down to number 9 so I get all the data. And my question is that data normal? Well, it doesn't look terribly normal, looks a little skewed. Okay, but maybe I could try my 68, 95, 99.7 rule and see how that goes. There's lots of options that we could do. The one I wanted to show you with the calculator was the one I mentioned at the end of class earlier this week, was the normal probability plot. Okay, that's where the x-axis is still going to be the data values. Instead of frequency, though, the y-axis is going to be z-scores. And if we see a curve pattern like the one we saw in the class slides, where it was those guinea pigs, right? The lifespan for guinea pigs, very skewed. We saw a lot of curvature to that. Then it's not very normally distributed, okay? But if we do this with our data here, maybe we can make a normal probability plot, which is this last graph here, right here. This, okay, now notice it's saying the data list is in L1. Which axis should we use for the data? A proper normal probability plot has the data axis as the x-axis, so leave that alone. That should be the x-axis, okay? Now I'm gonna go back to the graph, and I'm gonna actually zoom it so that it fits a little better. There we go. And what do you think? Do we have a nice linear look to this? Well, it's close, but I'm hesitating, guys, because as you can see, if I were to try and put like a piece of paper on here, there's some, I'm covering, it's like kinda, but there's this curvature down here that's gonna create a little issue for me. And there's this little zigzag thingy up here. We also have possibility of some outliers far out there. So I'm not totally convinced of the normalness of this particular data set. Judging from the histogram being a little bit skewed to the right, judging from the curvature that I see here in my graph, I'm going to conclude that I probably shouldn't try to model this data set with a normal distribution. Okay, it just doesn't look quite straight enough in terms of the line there. So sorry, unemployment data, you're not quite approximately normally distributed. All right, guys, so that's it. Pretty quick video. If you have any questions, be sure to rewind the video. And then if you have other questions, you can hit me with those questions in class either Thursday or Friday this week. Anyway, thanks for watching. So good luck with that TI-84. All right, see you guys.